Hi, I'm Tom. I'm going to talk about REPL-driven development. So in Python, as you may be aware, we can type Python and then type the name of a program. I forget what it's called here. Great. I can type Python, and then I put a space, and then say Python module, and then I can run this, and it'll do something. And we've got the title of this talk is REPL-driven development. But we don't have to always provide a file, right? We can just launch Python to run by itself. I can say Python, and it pops up here. I can import that module and say, let's import hello, and I can look around it. I can explore that object. Now it's this realized object that I can interact with. So I can say, what's the namespace of hello look like? And here we've got some built-ins that always are available. We also have this contact thing, and I don't know what it is yet, but maybe I could type hello.contact, and maybe the representation that the REPL shows me will be useful, and I can figure out what's going on. Oh, okay, it's a function. I'm worried I don't have enough space now, so I'm going to press Control-L, which clears the screen and moves me back up to the top, and now maybe I could run this function. So I'm still typing here. Pretend I'm still typing. Type. But I'm cheating, so I can talk. So you can call this function. We said it's sort of a self-promotional function. I want to talk a bit about using the REPL and how we can explore the language. We can explore a lot of things about how Python works, explore libraries. We're going to talk for the first 10 minutes or so about just how to use the REPL. We can write functions in our REPL, right? It's not a great text editor. It's not the place that you want to write large programs or novels or anything big, but you can write a function like this. We now have this defined function, and now we could call this function if we want. Functions in Python are objects, so we can get the types of them. And since we have the type of a function here, maybe I'm curious about that thing. I can save that to a variable. Underscore in Python means the last evaluated expression at the interactive interpreter. I can call help on that function object. So I just grabbed the class of the function I'm reading about. Like, oh, how does this thing work? Maybe we could build our own function. There's a constructor there. I always build my functions with def, space, and then a thing. But I guess we could do it with that constructor. So let's give that a shot. I'll still pretend I'm typing here. Okay, so I'm looking at that function object. We've got some interesting attributes on this. You can see how useful that dir keyword here is. We're going to read some more about that func code thing because I'm worried about constructing that for this function. I can see I'm going to need a func code. That is a nully constructor. I don't want to build one of those. But fortunately, the other day, I was just playing around in my interpreter, and I called dir on built-ins, and I was reading about the different things that are just available to me in Python, and I saw compile. I thought, that sounds like something I might need for code, and I read about it a bit, and it says, oh, it gives you a code object. So I can use this compile function to build that code object that I need, to use this weird function constructor. But really, I haven't read the docs here about these things, and that's what I should do after this. But right now, I'm just playing around in the interactive interpreter, and I'm learning about how this works. Okay, here, I'm typing this. I'm trying to compile some code, but it looks like I'm going to screw up the quotes, right? I have a single quote. Something's going to go wrong here maybe. I just use Control-A to jump back to the beginning. I'm going to save this intermediate result because it's nice to save intermediate results in the interactive interpreter and not to build big expressions because it's easy to mess up. Here I'm jumping back with meta B, jumping backwards. Meta F is go forward a word. So there are different ways I can do some text editing. It's not as good as my text editor, but I can try to get the quotes right here. I'm going to try to write a program that prints this thing here. I'm using double quotes inside of single quotes, so I don't have to escape them. Great, I succeeded. So it's nice to do these small expressions so I get immediate feedback about, yes, this worked, or no, this didn't work. I've already forgotten how that thing worked, so I'm going to read again about how that compile thing works. Oh, I should talk about briefly this str versus REPR, two different ways of representing a string of an object. Str is kind of maybe the more user-friendly version. Repr is the programmer-friendly version. You can see the difference here is that when I print s, that's the str, there weren't quotes on the outside. And on the repr, there were. That's giving me a hint about, hey, this is a string. Okay, I'm going to try to compile this now, but I've already forgotten what the signature was. So I'm going to call help on compile. Okay, I must have read it while you weren't looking really fast there. Okay, I'm going to try to build my code object here. S, that string I had before, the next argument was a file. I'm just going to try to put a file name. So I'm just going to try a random string here. And then exec was, I don't know exactly what that does, but it said it was one of the options. I'm reading the help again for functions to see how to build that function object. function of the code. It said it needed a namespace, so I'm putting that in there. I'm going to see if this works. Okay, maybe it did. F equals underscore, maybe I can call it. Hope so. Moment of truth. Yeah, great, it did it. So the point here is not that this is how you should build functions, right? We should use this great, we have lambdas, we have defs, those are a good way to build functions, but this is a great way to explore an interface you're not familiar with. It can be a new library, it can be, all right, now, sorry, we're back to typing here. We're looking at how I messed up. I'm going to try to get the source of this thing. This inspect module is nice for showing the source of a function or a module, which can also be useful when I'm just exploring. But it looks like my function this doesn't quite work with. So I didn't entirely fulfill the contract. I didn't quite do something that works. And if I'm trying to do something that works, I should read the docs. I should find out, oh, the right way to do this, or the spec says this is how to do this. But I was able to halfway get somewhere, and I think it's a really useful way to learn about a programming language, to learn about a library, to learn how to do something in a kind of fun way, and to have this passive discovery that's really useful, right? Every time I had the tab completion there, and I put a variable and a dot, I saw things pop up, and I could, or sorry, I haven't seen that yet, but just the discovery of calling dir on objects and finding out what's there, I think is really useful. So the next thing is maybe we shouldn't be using that the basic interactive interpreter. This is a fancier one called BPython. There's also IPython. There's PTPython. There's IDEs that do this kind of thing. You can see some fancy things it's doing here are popping up the attributes when I put a dot. I think this is really nice for that passive discovery that I was talking about earlier that I got to too quickly. But passive discovery like this has helped me discover a lot about Python without being looking for it. And if I don't know what to Google, I don't know where to read in the docs, I can just play with stuff here. We're sort of learning things about Python, right? We've seen that in Python 2, at least, things have this func code attribute. You can do stuff with it. There's this dis module that gives you a disassembled version of the bytecode, or a sort of an annotated version of the bytecode of a function. But we're just blowing past this stuff because it's more about here are tools that you can use in the REPL, and they will help you discover how things work. Okay, I'm promoting myself again, looks like. So this is kind of a tour of, oh, I guess we're still going. Okay, we're doing the function stuff again. It turns out that that function object is in the types module, so we can just say function type. Once again, we could build a code object. We could do all this stuff. I'm going to talk some about the specific tools. In particular, I worked on this project called BPython, so that's the one I know most about. If you're using your first interactive interpreter that's not the default, I think you might check out BPython, but really you should also check out IPython. That's kind of this big tool. Brandon Rhodes talked recently not the talk, I thought maybe it would be the keynote he gave here, but he writes new stuff and gives new stuff everywhere, I guess. But he gave a talk recently about how he had heard for years about IPython, but never tried it out because he never saw anyone using it until a year or two ago at a PyCon keynote, when someone finally, I think Fernando Perez, the main author of IPython, finally got up in front and showed him things. And I think there are issues with live coding presentations, but there's also tremendous use to finally seeing this. So today we're going to explore this stuff a little bit. Okay, I should be talking about the cool stuff going on with BPython here. You can see we're popping back and forth. We're looking at the help for BPython here. There's some fancy stuff it can do. I won't talk. I'll pay attention to what's going on here. Looks like we can build an object. We can do attribute completion on it. That's pretty cool. Is it looped now? Should we be done with it? Maybe it doesn't loop. You can see that this attribute completion, I think, is great for discovering how things work. Like, did you know how capitalize or center works? I didn't know there was a center. Then I could read the arguments. Oh, swap case doesn't take any arguments. I could just call it. So this is useful things for playing around, particularly with the built-in types, because that's knowledge that's just good to have off the top of your head in Python. It's nice to know what you can do with strings. And if it's a new library, maybe you don't need to memorize it, but it can be useful information. All right, let's move on. So my number one suggestion is use a REPL more. Maybe you are using it too much, but I think most of us are not using it enough. It can be tough because you can say, well, what task would be most efficient to accomplish in a REPL? And a lot of times you should write a script instead, but the additional benefits of kind of this discovery and of seeing every intermediate step, kind of like a debugger, which just comes naturally when you're writing small expressions in a REPL. Now, no, not big ones. If you build up big expressions, you're losing some of the power here because now maybe it'd be better to have a text editor or better to have your linter or something operating on this. But if you have small tasks, it's nice to use REPL, I think. Yeah, don't use the default REPL. I think you should use IPython or BPython, this thing I work on, or PTPython, which has great Windows support. It does some of the fancy BPython stuff. We have OK Windows support. This new project that uses the Python terminal prompt or Python prompt toolkit is really nice, and they have good Windows support. Zonch is one I didn't mention. Maybe it's Conch. I don't know. Someone's made a Python-compatible bash shell, and I've not really played with it much. It seems like a great idea. I mostly want to mention it because a lot of us already work on the command line, and we know how powerful that is, right? We know, oh, if I want to do a task, and a default one would be, I want to count the words of a thing and then pipe it to this other thing. But what if you had the power of the Python language at your fingertips every time you open a terminal? Maybe you could investigate this conch thing. It sounds cool. But that's what you have when you type Python. Once you get into an interactive interpreter, you now have superpowers. We'll talk about. All right, so I mentioned that I think there'll be some live demos here, and that's because I think it's so useful to actually see someone doing this, because sometimes that breaks the barrier, but it also means once we get out of the GIFs, this talk will be a little looser. Lisp, so REPL-driven development, in my mind, what that means to me is this style of, I'm in Emacs, and I have a buffer here, and I'm writing my code here, and over here I have a REPL, or I can't even see it. I just have my code, and I select some code, and I run that code, and maybe every line of text of code in my file, at some point I ran to see if I liked it, and then I did, so I brought it back. Also, there's a permanent or a persistent state interpreter running behind this. So I'm editing my file, but I also am thinking in the back of my head about the state of this interactive interpreter. And I can send code to it. There's plugins like Slime, and I've used like Vim versions of this too. I'm confusing the names of them. But tools that let you take code, run it, and then see the result of that, and also build up state, sort of like an R or a MATLAB kind of image. This idea of, oh, I'm kind of banging on the state of this thing by running some code in it. I think there's the reason I have this bullet point here is because I don't actually do that. I don't use Emacs, and I've done very little work in any Lisp environment. But I'm going to talk about it as though I have, but it's all secondhand experience, just so you know. I don't really know this. I call this REPL-driven development. As I said, I think of REPL-driven development as that idea of taking code and running it from your text editor. But I'm mostly going to talk about how cool REPLs are generally. Yeah, and it'll be interactive because I think we have a relatively small audience. I'm going to ask for questions in a little bit. If you want to start thinking about questions, halfway through I'm going to say, what would you like to talk about with REPLs? So REPL, this word I kept using, that's a read, evaluate, print loop. There are, again, like distinctions you could draw. It's like, oh, well, the Python read isn't really the same. Or Python raw input isn't the same as like a Lisp read, and so maybe this doesn't count. But the idea of let's put in some code and get back what it evaluated as is still useful. It could just be something like this, right? Like IPython is like millions of lines of code probably now. It gets more complicated than this, but this is the idea. Let the user type some code, evaluate that code, spit out what it was. And maybe instead of eval, use exec so you can persist stuff or something. What is it? Good for understanding a language. This is one that I guess maybe because for the last few years I've worked at a kind of education place, kind of a programmer retreat. I've emphasized this one most of all. I think the overhead is the smallest for, I want to know how Python works. I will look at a few of these later. I have some WATs about Python, or I have some things I don't know, or how does operator precedence work? I could look this up, I could go Google it, or I could try to remember how this method works or what the arguments are, but often it's quicker and, in my mind, more enjoyable not to Google this, but to jump over to the REPL I already had open and try some code. I think it's a good way to quickly gain intuition about kind of how Python works or how its syntax works when you get those errors immediately, although you could do some of this with the linter. Exploring a library, exploring an environment. We do this in debugger sometimes, or we do this when we have, debugger is the main example, and we'll look at that in a sec. I want to know what's going on in my code at this point in a program, and so I could put in there, open a debugger, and then I can use debugger commands to read variables. Or I could say, open a REPL, because I'm comfortable in REPL, and let me look around at the variables that are here. Let me have my tab completion and things. And then finally, having superpowers, this is the conch shell example from before. If there's a library like requests that lets you do a thing, make requests, HTTP requests of servers, you can do that with the command line. Maybe you have to use curl if you already know curl, but if you already know Python, then knowing the library exists, or maybe the GitHub API. I had a lot of fun with this a few weeks ago. I heard about this new GitHub API, GitHub 3, I think it's called, for Python, this library. I opened it up, I started using it, and within a few lines of this Python stuff, I was finding out things I couldn't have gotten from the web. I was doing this neat interactive exploration. So at no point did I ever copy this out and put it in a script. I just wanted to know an answer. So some people call this knowledge computing, where the point of the programming is not the software at the end. It's actually some information, a question I wanted to answer. So I think REPLs are great for that. Right, you get faster feedback. We should mention. So who's familiar with doc test? Anybody? Who has strong opinions negatively for doc test, kind of? Yeah, okay, yeah. There's this neat thing called doc test that we'll look at real quick. It's this idea that if I have a session here, oops, I'm already in a thing, and I said, hi, I want to check, I'm going to write a function, and I want to check that it really does what it says it does. I can say, all right, I want to make sure that when I call this function, it really does give me 3. I could copy and paste this right here and put that in a doc string. Say return a plus 1. Oops. And then I could say import doc test. And what this will do, it says, okay, that was fine, but if I said 4 here, then, then running this would say like, hey, this failed. So this is a very quick way to write some tests. There's a lot of power of testing you're missing out on when you use it, but you do kind of get some regression tests for free maybe. You could just, I played with stuff and then I copied it out. I think its point is that if you have documentation, maybe automatically generated documentation that comes from your doc strings, examples can be really powerful. This way, your examples never get out of sync with your code. So it's a weak regression test that is just, does this documentation still accurately describe what's going on? Faster feedback, I mentioned this small expressions, right? Yeah, I could run a whole script, but it would be fun to just do little bits at a time. Okay, a benefit of playing with your objects in a REPL similar to test-driven development is what TDD stands here for. I find when I think about how will these interfaces work in a REPL, if I were to take the code that I'm writing and then hop over and import it in a REPL and start playing with it, does that give me the superpowers I want? Does that let me do the kinds of things I want to do? I think test-driven development is this idea of I will actually write code that uses my interface before I've written it, because that will help me think about how to write it in a more testable way. I think this is a weaker version of that, but it's a cheaper version too. If I'm just thinking all the time about, all right, I wrote a little code, now I import that code in a REPL, and I try to play with it, and like, oh, it doesn't really do what I want, or I can start to play with it to see if it does do what I want, some testing. Again, that's not as persistent as testing. It's not, I'm not thinking as critically about it, but I'm quickly getting a sense for how this code works. This is helpful at making things useful by themselves. So this is thinking, maybe I should have some default arguments that like how friendly a interface is in the REPL is not maybe necessarily a great indicator of how useful it would be as a library, but it's a thing to think about. It's like, all right, does this library, does it have some high-level thing that abstracts away some of the details that lets me say something like download a file and search for all the occurrences of the string in it if you're writing an HTTP library. All right, so here's a question. What does this do in Python? The sort of interesting thing here, right, is that count each time I call it is going to increase by 1. And so I think this basically comes down to, does this run first or does this run first? And if I'm showing it was something that wasn't immediately intuitive for me, right, I kind of thought, oh, that's kind of left to right. Maybe I was right, maybe I was wrong. I'm not going to tell you. You should open up a REPL and find out. This is the size of example that I think works well for a REPL, right? It's not too bad. Maybe if I'm in IPython, it's nicer because I can use that undo key to if I make a mistake. You could definitely just write this in a file, but I think it's easier to kind of check the assumptions each time. I can, once I get down to this line, I can make sure that I do have that attribute on there. I think it's fun to, it just feels more immediate to me than looking at the result of this script as a script. It's more fun to have it as a REPL, or interactively be trying it in the REPL. And sometimes I feel like I don't really believe it if I just see it as a relative script, but once I try it step by step, I feel better about it. Here's another one. It's just operator precedence. Sometimes I don't immediately know what's going to be. I'm 95% sure, but I'm not 100%, and that's uncertain enough that I'm going to hop over to a REPL, try the expression I was doing, be like, oh, okay, that is how operator precedence works. And then maybe I'll go look it up to find out, because I want to know really how it works. Or maybe all I care about right now is the thing I'm doing going to work right? This one, the thing that I forget sometimes is, oh, right, in Python you can have two different comparators, and those are separate. This is not saying, is 1 plus 2 equal to, well, who knows what this is saying? You should try it in a REPL. You can try putting in parens in different places, see how that changes it. This is a particularly tricky one that's just here in case the other two were immediately obvious to you. What you get might surprise you. Who knows? You should try it in a REPL. All right. Where do we use REPLs? We talked about this a little bit before. PUDB. So if you have a Python debugger, and I said, let's do PUDB, this thing. This is this fun graphical debugger. Pretty cool, right? You could learn how to use this. That would be great. You can set watches. You can do interesting things with it. But maybe you don't want to learn how to use it. And, whoops. Maybe you just want to learn how to use it well enough to get to the spot in your code or use a breakpoint or something. And now that I am inside of this foo function, I would like to start a REPL. So I can say exclamation mark, and it pops down here, and I can, this is this little REPL down at the very bottom of the screen where I can say, oh, what is the value of A here? Oh, it's 1. Cool. And you can, a good thing to know about this is in the settings. Where are the settings? Question mark help? Anyone know where? Not sure where the settings are, but in the settings, which open the first time you open this PUDB program, which you can pip install, it says what interactive interpreter do you want to use? And you can use IPython, you can use IPython. Next up, the Flask debugger. So there are, if you're in Flask using a debug server, you can either, when there's an error, or you can kind of manually trigger it, say, I want a REPL in this situation. With these variables all set up the way they would be when I was running the request function. The Django admin shell, this is more of a superpowers one. What if I want to, I probably should write a script for this, but what if I just want to see what my models look like? What if I want to actually do a migration manually? I've written I probably shouldn't do this, but I can play with the objects and see, or I can, at some point worked at a company where there's a thing you want to know, and so you use an interactive interpreter to jump in, talk to your database with your ORM, kind of the model's already attached, and maybe you need to know one person's name and that's not exposed in some other interface. So you using this code, you can get these superpowers. IPython, we'll look at this in a sec. This is the tool you should be using, and I would really encourage you to watch a video of somebody using this tool. It's tough because it's especially the notebook interface. Now IPython works in a terminal and there's a notebook interface. The notebook interface is a little foreign to some of us if we're not used to kind of browser-based computing things, browser-based interaction, but you should check it out. All right, what is REPL-driven development? This is, in my mind, what it really is, what other people talk about is running code from your editor. Either I can select some code and say, please evaluate this and show me the output, or please evaluate this in some context, right? The function doesn't make sense when it's in the wrong context, so you have to think about, all right, have I already sent the global variables to the REPL before? Running selected code, maybe I mean run this script up to a certain point, or maybe I mean, all right, run this whole file, but leave me in the situation where I can see the variables that I created in that file. All these are things you can do with IPython. Okay, so all the other material I have is specifically about reloading, which is a particularly thorny issue with getting the code you have in your file into a REPL, and then changing the code in your file, getting it back into the REPL. But I would like to talk about, or I'd like to take questions first on REPL things, and maybe I won't know the answers, but we can put them up. Does anyone have questions about using an interactive interpreter in Python, maybe why you might want to, or frustrations you've had with one before? Anybody? Is anybody kind of critical at this point? It's like, why would you really? That sounds cool, but I use an editor or an IDE to write my code. I don't understand why I'd want to use this command line interface.
I think the biggest frustration with the REPL is that, for example, you have multi-line statements like function definitions, and you forget that it's that the prompt has changed really, and the ellipsis, and you forget the indent, and 2 or 3 lines down, and you press enter, and
Yeah, that's a great point. So these are not text editors, and they're not great for this. There's one I don't have installed called IPython that does this really nicely, that has great multi-line editing. You can say like, oh, I want Vim or Emacs key bindings, and it will kind of let you edit this. The way we do this in IPython is not ideal, but I can pop down here and start writing the rest of my code, right, v equals 2. So it does the auto-indenting. So does IPython. So those are things that we just don't use the default interactive interpreter. That'll be better. But the other thing is I can hop back a line. I can say, oh, I screwed up. This is not as good as me being able to move the cursor up and change code from before, but I can do that. So I can run this function now. Something else that I could do when I'm up here, let's return A plus B. I call the function. You know what? I wish I had changed that, but I don't want to delete my code. I can press, in IPython, I can press F7, and it throws it back in a text editor. I can go back, change this stuff here. Whoops. Change this, and it updates my session. There's also some nice, cool. And this is where IPython deals with this with reloading. You can grab a previous thing that you've typed, stick that in an editor, and maybe you can start importing it now, or you can go back and redefine it. An issue you run into, so I'm saying another way we could do this, if we were using IPython, the way this would work is I write this function here, and I say, oh shoot, I wanted to edit that. Well, I have multi-line history, so I can pop up there and redefine foo. I can pop up there and redefine foo. I got this by pressing up arrow, and now change it like, oh, I wanted it to be 2. And now, right, I've created a new binding. I've rebound the global variable foo to this new function, which mostly works. But this is where we get into some funny things, where what if some other function had a reference to the old foo somehow? Now, mostly if it's a global variable, things are going to relook that up. But there could be issues with having these old references. So when you start redefining things or importing a file and having that overwrite things, we have to start to be careful. That's what some of the reloading is about.
Yeah. I'm very new to Python, so maybe this question is very easy to answer. I don't know. But I've been learning Python recently, and for example, if I'm writing a file,
yeah.
I try to run the file via the interpreter.
Mm-hmm.
I noticed that if I change the file, I need to re-import the model. Is there a way to actually watch the file for files and make it re-import the model automatically?
Yeah, there are a few ways to do this, and they're all a little bit weird because it's kind of a fancy feature. Let's look at just doing it in a normal Python interpreter first. So if I'm here, I just wrote a file called, I think I call it test3, and right now it prints hello each time I import it. But say I import it again. I'm like, oh, okay, I updated it, so let's go update it. Right, and now it also defines a function called foo that prints hello there. Or so when you call the function, it's going to print there. And you're saying, I want to somehow get this into here, right? I want to get the new stuff I've done over to here. So in the default interpreter, if I say import test3, we might think it would do that, but it doesn't. In fact, we can tell that because it doesn't print hello again, that means that code's not running again. So when you do this, the modules are cached in this global, this sys.modules location. So we have to say reload test3. In Python 3, they've taken reload out of the built-in namespace, and you have to go get it from somewhere else, because it's just not a great idea. It just doesn't work great. The way this is going to work all right, because this is a pretty simple situation where nobody else has references to this one. Maybe this file doesn't import other modules we might want to reload. So when I say, reload here, that I am going to have a new version, and test 3 now has a foo on it. And if I've changed foo, this would work. So this works up to a point, just using this reload function. A nicer thing, the way I do this with IPython is I can import test3 here, and then I can say test3 dot foo. How is this supposed to work? Okay, it prints there, but I want it to print something else, some nonsense. I can save that file, and over here hit F6, and we'll rerun the file, re-importing all the modules. And there's even an automatic watch version, like you're describing. But I like this way of doing it because it's kind of what you describe. But keep in mind that everything happens again, right? If I say import time, time.sleep for a second, and then I try to do something with that module, test3.foo, and then I was like, I'm going to make a change here and make it just exclamation mark, and pop over and reload. It now takes a second to do that because it's redoing everything it's done so far. That's the safest thing to do, right? To really start over. And the safest thing to do would be to kill the interpreter and start it again. So this is a sort of safer side of the continuum, but then IPython has some cool auto-reloading things that maybe we'll go ahead and look at a little bit. So we have to do reloading. This is solving a bit of that problem. This is my first Stack Overflow question from 6 years ago or so. I inherited some code that looked like this, and I was confused. Why would you want to reload things over and over here? What's going on? And the first few answers were like, that's ridiculous. Why would you do that? But then someone pointed out, a reason to do this is that if someone reloads this module, that will trigger a reload of each of these modules. And so that could be a good system, but you don't want to do this in all of your files for reloading. Maybe you do for a moment if you're going to be doing that reloading, but that's not great. So there's a hard problem, and people solve it different ways. Right? This is nice. Thank you, Gareth Rees, whoever you are. IPython has a deep reload that tries to solve this by going through and saying, you reload this, I'll go reload these things. But that can be hard because you're reloading the code down here, but you might have other references to code from before. If you've ever said from module import A, and that thing's not a module, then it wasn't a package you were importing, that you're just getting a function in here, then that could be a problem. IPython has a solution to that, which is IPython's kind of auto-reload, which will watch files. It can't do from module import foo, where foo is a number, but if it's a class or a function, it puts a little wrapper object around it and updates that as it's going. And when I say this, it should be like, that sounds really neat and a little scary, because this is the stuff we're talking about here is no longer really Python, right? It's not, if it doesn't work in the vanilla interpreter, then it's a little different. And for all these fancy interpreters, as soon as you have a bug, one of the first things you do is you try it in a script, or you try it with a default interpreter, because they could be doing funny things here. So these reload systems are great, and I think it's maybe even worth learning to use one, but to learn to use it, you need to know about its deficits, and that has to be one. You add that to your list of suspects every time your code's kind of broken in some way. All right, so I'll stop with reload for a sec. Anyone else have thoughts about, questions about REPL things? Difficulties you've had? You know how much time is left? We're 15? 5. Okay, cool. So don't trust reloading. This is the message. It can be useful, and if it's saving you time, great. But you have to include in that calculation the time it's taking to debug these extra problems. There's this idea of saving an image instead of saving the code. So in some environments, say in R, we bang away at our data, and we change, we create new global variables, we do stuff, and then we can save the image. We can say, all right, and then restore it later. And when it's restored, we don't rerun all the code we ran. We just say, all right, at the time I had 17 functions, restore those. I had this data, the data was in this state, restore that. And I was talking to someone, about this, and it's like, wouldn't that be neat? This is this neat idea of the way I program in Python is that I add new functions, new objects to this global state, and then my program at the end is whatever I ended up with. And I don't have to worry about how I got there. And I don't know solutions for this in Python. And generally, I think we say, well, that's a bad idea. Don't you want reproducibility? Don't you want to have exactly the code it took you to get there? And if I try to recreate state in Python, I probably don't pickle my environment and then try to reconstitute it. I probably look at the code I've run and run it again. That's why I'm interested in this, and this is sometimes what people mean by, or at least is the thing that's involved with REPL-driven development, when your product at the end is not your code, it is this saved workspace. It's like, okay, well, I have an interpreter now that knows how to do these 17 things because I taught the interpreter to do those. I defined those functions, but not worrying out the code. But in general, in Python, I found it's not a useful way to do things because we don't have great tooling for this. And just the idea scares me, too. It's like, oh, no, I want the code that I used to get to this point. All right, so how do you do work on a module? So this is about kind of trying to use REPL-driven, using the REPL for real work. Maybe in Python you use this magic run thing, which runs the file but then slaps the variables into your namespace here so you can play with them. Exec file, you can use python-i, which runs your file and then sticks you in an interactive interpreter at the end of it in that same namespace. And IPython and IPython do this too. Okay, and I don't have this one. So that's kind of it. The why, again, is that I think it gives you intuition for your programming languages, which is really useful. Being able, for me, it's been very helpful over time to build up thoughts about, okay, I can look at this Python code and kind of know what it's going to do because I've typed it out a lot of times. And for me, this is stickier information, this is stickier knowledge than reading the spec. And maybe reading a spec or reading an explanation of something crystallizes something and say, I have these 17 data points and those match, right? When I read the docs, it says, oh, that makes sense because this, because this. But I think it would be useful for most people to spend more time interactively typing. And I think it's a more rewarding, even at the level of, oh, I get my dopamine hit in 7 seconds instead of 30 seconds, right? I'm not, just in the same way that it's important to keep your development process kind of tight. It's nice not to have to wait 30 seconds for your code to compile, and we like Python for this, right? I just run the code right now. It's nice not to have to wait for my program to get to a point. It's nice to just play with these objects right there. So that's it. Thanks. Oh, right, yeah. A guy named Bob. Let's say it stands for better or something, I don't know. But there's a guy named Bob that made it.
The second question is, when I'm working in a REPL, I usually find that the stuff starts out as something simple, frequently sort of starts to get out of hand, and then I find myself having to say, all right, let me take this REPL and move it into a script. Do you have any suggestions for how to do that?
I think that's, as you described, that's a reasonable thing to do. It's nice to be able to grab the REPL session and edit that down instead of going back and copying and pasting. So IPython has something for this, and I don't know what it is. In IPython, that send to an editor thing I showed before, sometimes I'm not doing it because I want to change it. I just want this as a session. There's also like send this to a paste bin and create an artifact out of this. And I think that's exactly the process that you want to get into, kind of that tight loop of like, all right, I start to have an idea, now I move it into a file, and I start editing code, but then importing that into the REPL and playing with it here. So I still have my interactivity, but I'm not trying to edit text in here. And I think there are solutions to this that are getting better. And IPython, I really should look at IPython Notebook for a sec, because it solves some of these things, right? Like this is kind of a text editor. There are plugins to make this more like a text editor. If you've not seen this, right, this is where I'm writing code, doing stuff with it. We have this problem, though, of there is an invisible interpreter session behind this. So say I make A be this number, I define this function, and then I write, and actually A is 12, but let's delete that. What is A now? Well, it's 12, but I can't tell that looking at this. And so I think the IPython Notebook can be a more dangerous version of this, but also it lets you write more code while you're here. So as long as you limit yourself to things where you're redefining a function and that's okay, you can keep more code here. And still, people will start to write it and then, okay, now I'll select things, move them out into a module, import that module. And if you're using IPython Notebook, I think the thing to be really friendly with is this restart and run all. You want to do this, maybe you have code that it takes a long time to run, and so it's nice that in IPython I can choose not to do that every single time. In IPython, my undo reruns everything. But you